Hey everyone, I'm Anesha Naskar, and I'm introducing everyone to this IBM Developer Tech Talk series. Today we'll be going over Kubernetes. So this is titled Learn the History and Fundamentals of Kubernetes. Our presenter today is Ed Shi, and he'll introduce himself.
Cool. So yeah, hey everyone, I'm Ed Shi. I'm a developer advocate working for IBM Cloud with a focus on cloud deployment. So containers, serverless, virtual machines. Those are kind of the key features of what I focus on. But also I do a fair amount of machine learning and artificial intelligence as well. So.
Okay. So throughout this talk, I'll be monitoring the YouTube chat for comments and questions. And in the YouTube chat, in the description box, there's a link to the event page. And in this event page, you'll have a replay of this video and getting started resources that will help you take the next steps in learning Kubernetes, along with a link with how to sign up with IBM Cloud. So Ed will begin now.
Cool. Yeah. So what I will do, just before I start, just check I got my slides up on the screen so that you're ready to go. Okay, great. Yeah. So try and not bore you guys too much with too many slides. What I'm going to do in this talk is I'm going to take you through some basics of containers and Kubernetes and where it came from, and just a few of the important things you'll need to know. And then I'm going to do live demonstration because I think it's the best way to learn is to see how it's actually done. And you can see it live. And this is actually also available as a workshop if you want to do it. I'll share the link with everyone afterwards. Okay, so let me just share my screen. Cool. And Anisha, could you just confirm you can see that? You should be able to see the introduction.
Yes, I can see you.
Okay, great. So just to reiterate what Anisha said, if you're on this event page anyway, there are resources you can go to. You can find all sorts of things around Kubernetes and so on. The workshop that I mentioned, some of which is covered in this talk, if you go to Kubernetes 101 on the left, and if you're interested in signing up for a free IBM Cloud account, go to this link on the right-hand side, and from there you can start playing with all sorts of resources and services on IBM Cloud. Great. So the agenda for today, I'm going to loosely cover container architecture. This talk kind of assumes that you have a basic understanding or at least are familiar with containers as a concept. You don't necessarily have to have had hands-on experience. Talk about the advantages of them, then talk about Docker and how that kind of revolutionized that container ecosystem. And then some of the stuff around Kubernetes, why it came about, where it came from, and the basics of Kubernetes and how it works. And then some key concepts of Kubernetes. Then I'll do this demo I talked about. And then finally, I'll just come back to the slides just to wrap everything up at the end. So to start with, just for those who aren't necessarily familiar, containers essentially have taken what was the virtual machine operating model, where you have a hypervisor, and in each of those you have an isolated segment of compute that can run its own operating system. The difference with a container is that they share a host operating system. So you still work in an isolated environment, both in terms of compute, memory, processes, etc. But they're actually all on the same Linux host operating system. And so what this allows containers to do is to be incredibly lightweight and way more portable than a virtual machine is. And I know, for those of you who've had experience in this, trying to share virtual machines with each other when you're sharing images, they're often tens or hundreds of gigabytes. Containers tend to be in the range of megabytes, tens of megabytes, hundreds of megabytes if they're very big, but it's normally the stuff you put inside it that makes it big. It's not the base image itself. Whereas an operating system, already by default is taking up gigabytes of space, right? And so they're much less portable. The other thing is they don't have the boot up time of an operating system. So containers can start in milliseconds, where virtual machines were starting in seconds if they're really fast, but mostly minutes. To show you how this kind of makes it more flexible in terms of how you run your compute, the other thing with a virtual machine is that they are constrained from when they start in terms of their resources. So if I have this example on the left-hand side, I've got a virtual machine with a hardware node, and it's got 4 apps on it. I've provisioned those into that machine, but I've reserved a quarter of it for each of those apps, and actually none of them are using the fully allocated resources that I've given them. With containers, you don't have to constrain them. You can constrain them with Kubernetes, and you'll come on to see this later. But it also allows you to get more utilization out of the hardware you have underneath, because typically they're smaller, lighter weight. They have fewer resource requirements in the first place, but they also don't necessarily need to be constrained. So if one app needs more compute than another, it can take it. So then bringing on to Docker, right? So Docker took containers, which actually have been around for a long time. They were since the 80s, but they weren't very popular because it was a very difficult deployment technique to use. What Docker did was took the container system and made them developer friendly. So they built a nice experience, a user experience around containers. And the way they did this was they defined some key components. Like on the left-hand side, you see the registry, right? Inside a registry, it's essentially a store of built containers. And what gets stored in there are container images, so which you can see in the middle, just under where it says Docker engine. An image is the same as a virtual machine image. It's like a blueprint of a built container that contains all the code and dependencies required to run your application, right? Those images then get run and they're instantiated into a container, and that's what actually the container is it's a running version of the image that you've built. Those are built through a set of instructions called a Docker file, right, which you can see on the right-hand side. And so Docker built this very simple ecosystem, but it actually made it really easy to reuse other people's assets. So I could take one of your images from the registry. I could use my own Docker file and just build my own application information into the image that you've already created, and then I can run them as containers. When I have a running container, if I also want to capture the changes I've made in that, I can commit that, and it creates a new image from the base image that was used. So Docker kind of made this really nice, and running containers was then a sort of a much easier problem than it was before. But Docker has a lot of limitations when it comes to running things in production. So if you read this problem statement at the top, I have multiple applications that I wish to run across multiple servers with high availability. Docker is great, but it's not that smart. So some of the limitations of Docker, so Docker is only aware of the containers running on the machine it runs on, right? And that's the biggest one here, is that the Docker engine runs on a single machine, and it has no awareness of the fact that you might have multiple machines with multiple applications running on them. So it's also inherently not aware of its own state, right? So actually, if your machine totally dies, your Docker engine dies with it. So Docker doesn't even know that your containers underneath are now no longer running. Horizontal scaling in Docker doesn't exist. So yes, you can run, you can say, here's a container, run it, and then run it again and run it, and you can keep running the same container, but it doesn't have it built in by default, right? In the way that with Kubernetes, you can scale things easily and independently. Docker also doesn't repair applications which become unhealthy. So with a Docker container, if I deploy my application in there and it's running on an engine in a single machine, and then it crashes, Docker can report back the status saying this application has crashed, right? But it doesn't automatically understand, not necessarily why my application's crashed, but that the application has crashed rather than necessarily just exited because it's finished running a process. And it also doesn't know that actually I want that thing to be restarted. I still want to always have one of those running. So it doesn't have this kind of understanding of the desired state of your application landscape, which is, again, as we come to Kubernetes, you'll see that that gets managed very well. So just to explain where Kubernetes fits in, this is a kind of very abridged version of different sort of container stacks. So right down at the bottom, you can see physical infrastructure, right, which was, I guess, how traditionally all computing was done. You buy your own physical machines. On top of that, you have virtual infrastructure, things like VMware or EC2 from AWS. Operating systems, again, these are now abstracting even more. Inside your virtual machine, you're abstracting stuff through an operating system. Inside those, you might run a container engine, right, which then isolates that operating system. And then, like, a sort of even higher abstraction to that is this kind of orchestration scheduling service model, right, which basically takes multiples of those layers that we've talked about beneath. So in this case, container engines for Kubernetes, right, and handles the deployment and scheduling of workloads across those. The final one, just to mention at the top there, is more of a like developer-focused orientation to that. So if you look at things like OpenShift or Heroku or Cloud Foundry, typically what's referred to as PaaS or Platform as a Service. These tend to take a much more, they're more opinionated, but they will take a more developer-centric approach, where actually I don't really care how my application gets deployed and where and so on. I just want it to run, and here's my code. So it's like a code-first approach. So just before I talk about some Kubernetes capabilities, let's talk about sort of where it came from. So originally, it came out of a project inside an internal project at Google called Borg, which was their workload scheduler, which would allow their developers basically to spin up their own environments super easily and quickly, and it was built using containers. It then became its own open source project. It's been backed by huge corporates, IBM being one of them. Google is still heavily behind it. You'll see Red Hat, even Amazon, who traditionally have been pretty anti-open source, have caved in and are now backing Kubernetes as a container orchestrator. And it's its own, now through the Cloud Native Compute Foundation, has become its own foundation, which is great. It was the first project to fully graduate from the Cloud Native Compute Foundation. If you're not aware of what that is, Google it, because it has some great tools and utilities in there that allow you to run distributed workloads at scale on the cloud using best practices. Another fun fact, right? Kubernetes comes from the ancient Greek. It means helmsman or captain of a ship. And as you start to see some of the capabilities that Kubernetes brings to your container deployments, you'll see why it's named as such. So one of those is intelligent scheduling. Kubernetes will take your containers and it's automatically placing those based on the required resources. So if I have, let's say I have 3 machines, right, and one of them's running almost at capacity, another one's kind of half full, and the other one's pretty empty, right? Kubernetes is aware of that, and it knows, okay, the best place to deploy that extra container you now want to run is in the pretty empty one. There's loads of resource there for them to run. It also, supports mixed workloads. If I tell Kubernetes I want my application deployed 3 times for high availability, right? In fact, I don't even need to tell it I need high availability. It assumes as much. It will take your containers and it will run them across as many different worker nodes as it can in order to increase the availability of your application. Another thing Kubernetes does is it self-heals. So it has a concept of a health check, and it understands, and you can define what it is that it's checking on your application. But it will restart containers that fail those health checks. It will replace and reschedule containers if a whole node dies. So a node is think of it as like a compute pool, I guess, right? Or a physical worker that is running your containers. If that entire machine goes out, Kubernetes is aware of that, and it will then replace and reschedule those containers onto other machines to make sure you always have as many as you need. It also will kill containers that don't respond to your health checks if you define those. Kubernetes is fantastic at horizontal scaling. There's a simple command, I'll show you this in the demo. But you can say, okay, that container I'm running, I actually now want 15 of it, and it just immediately scales those up. You can also do automated scaling based on the usage of those. So if my application is under heavy load, I might want it to automatically scale up and add new containers. But also in a scenario where it's now nighttime and fewer people are using my service, it can scale those down as well. One of the other problems you have when you're running containers in a distributed way is how to route traffic from those containers to each other. So, and if I give you an example, right, let's say I build a little microservice that goes and fetches customer details from a database, does some sort of manipulation on that, and returns them to you. And as a team, we want to reuse that microservice quite a lot. We need it in a front end. We need it in a bunch of other services that, depending on the industry, right, you might be doing all sorts of things. If that's running in multiple containers, how do I allow other services to connect to that? Even more difficult, right, in a kind of old school deployment is if I'm now scaling that. So now I've gone from having 3 versions of it, or 3 containers. I now have 15 containers. How does it know that where those new, the other 12 containers are, and how to connect to those? So Kubernetes has a concept of services and service discovery. So when your service comes online, it registers with the Kubernetes service broker, and other workloads that are running in there can then connect to the service broker and say, oh, hey, where's that service that Ed built that retrieves customer details for me? And the broker will say, okay, here's your connections string. You connect to that, and it automatically then does load balancing across all of the running containers to make sure that your request is always served, right, regardless of where the stuff is. Because ultimately, the containers underneath are ephemeral. They should be stateless, right? A lot of people don't run stateless workloads in Kubernetes, but it means that they may be in a totally different place to where they were last time you connected. It also has automated rollouts and rollbacks. I'll show you this in the demo. Essentially, you can roll out a new version of your application if things don't go correctly, or you're failing health checks, or you're monitoring it, and something goes wrong. You can immediately roll that back with a single command. Another thing Kube does is it handles secret and configuration management. So if I have let's say there's an external API I want to connect to, and obviously, I should know better than to write the API key in my in my code, right? We shouldn't be storing it there. But maybe I think, well, I want to put it in environment variables and so on. Well, you don't even need to do that. Within Kubernetes, it has an encrypted key store that can securely store all of those application credentials you might need. And then that application, when granted access, can retrieve those and then use that to connect to, in this case, my external API that I wanted to speak to. So just very quickly before we dive in, a couple of concepts in terms of naming that are important. So actually, just before we do that, this is a very, very simplified kind of architecture of how Kubernetes works. And if you look right in the middle, there's this database, etcd, right? And that essentially, right, is at the heart of everything Kubernetes does. What goes in there is, as a user, I tell Kubernetes, here is what I want my application landscape to look like. So it might be, I want this service deployed, and I want 5 versions of it, and I want each of those versions to have 3 different containers running and across as many machines as possible. And then I might have another service, and I say, I just want to run 15 containers of that. Right, that all gets stored as what is called the desired state. And then these controllers that you see in the top right-hand side, these are continuously monitoring your application, your actual deployed state, right, and checking against all those machines. Okay, what are you running? What's your resource utilization at? Have any of those apps returned exit codes? Have they crashed? And it takes those and it checks them against the database, and essentially it's just doing a diff in those 2 states. And so if I've said I want 3 containers to be running, and there are only 2 in my actual landscape, Kubernetes, this is where all the logic within Kubernetes automatically takes care of that for you. So it will say, oh, well, I only have 2 and the desired state is 3, so I need to schedule another one of those containers, right? And that's where the intelligent scheduling comes in, and it'll say, here's the best node to put it on. I'm not going to put it on one where the other 2 already exist, etc. The final piece in that is that you see the API server above that, where this handles all the requests that you do to it as a user. The controllers talk to it. Essentially, it just handles the database access. And then in terms of terminology, there's a master node. The master node is the bit that runs all the kind of Kubernetes magic right underneath. So it controls, manages the cluster. It's what you communicate with from the kubectl command line. Has a REST API for communication with workers, and I guess any external tooling you might use. And it handles all the scheduling and the replication logic. The worker nodes within Kubernetes these are essentially your compute resources. These are the ones that actually do the work for you, and hence worker node, right? They host the Kubernetes services that you deploy. They do have a few other little things on them. So they have kubelet, which accepts commands from the master and actions those on the host. It has proxy, which, as you would expect, proxies the traffic to and from those containers inside the worker. To understand, when I mentioned the fact that it has a service discovery and load balancing, the kube proxy handles that piece for you, so you don't need to. And of course, it actually runs the container engine inside. So in this example, it runs Docker engine. One of the interesting things about Kubernetes is it doesn't run any of your containers. It requires you to bring your own container runtime. And actually, in the vast majority of cases, this tends to be Docker, but it doesn't have to be. And that's one of the cool things about the Kubernetes design, is that as other container runtimes develop, you can swap them in and out. So if you eventually wanted to run, I know there's a lot of work going on with Windows containers, being able to isolate the Windows operating system. If you have very specific .NET applications that have to run on a Windows host, right, you should be able to do that whilst using Kubernetes to orchestrate those. And there's also, IBM contribute heavily to a container runtime called Containerd, which is essentially trying to take out. So Docker's great, but I mentioned all the user experience it gives. When you're using Kubernetes experience, because the engine in there doesn't do any of the scheduling and checking of the containers, right? Kube is doing all that for you. So all the engine needs to do really is literally run the containers. And it's using Docker is probably overkill for most of the scenarios. So what Containerd does is like stripped this down to be a really lightweight and fast container runtime that really just does the basics of executing and running those containers. And then Kubernetes does all the fancy scheduling stuff over the top. Another thing you'll need to know is pods, right? A pod is essentially, you can try to think of it as like a container. It's not a container because they can contain multiple containers, but it's the smallest deployment unit in Kubernetes. So every application you deploy will be in pods. The reason I mentioned it can be a collection of containers is that on their own, like, you generally shouldn't put multiple containers in a pod. Like, let's say my application has like a front end, a back end, and a database. Like, the last thing I should do is put all of those in a pod, because then I can't scale them separately. Everything in the pod also, shares a namespace, network, and host name. So again, they may have processes that conflict with each other. The only, like, in general, keep things in separate pods. The things that do make sense to put in a pod alongside your application container are things of what they call the sidecar model. So let's say you have like a logging agent, right, that takes all of the logs coming out of your containers and it pipes them all to some central repository or to a third-party service or something, right? That's something you want to deploy alongside every application that you do. And actually deploying it inside a pod next to the other container is a good deployment technique because, it shares the common processes, the namespace, network, and host name. And it's not actually affecting the running of the container itself. Also, they tend to be incredibly lightweight, right? And you would need to scale 1-to-1 with each of the application containers as you scale them. Labels they're simply just metadata, right? They're just key value pairs, but Kubernetes has a really good way of filtering and searching on these, like in a super fast way. So try to write labels for your resources as much as possible. Initially, when you start playing with Kubernetes, it won't matter because you'll only be deploying, a small application or a couple of applications. But when you get into, huge scale deployments where people are running hundreds of thousands of containers and often thousands or tens of thousands of applications, being able to debug which of those containers and which worker node and which application gets very, very difficult if you don't have labels, because the IDs give you very little very little information on their own. And then services, these are essentially a way of describing what your application or your microservice looks like within Kubernetes. So it's, as said here, a collection of pods exposed as an endpoint. It's essentially saying these three containers that I've just deployed, I want those to be described as my, my get customer details service, because then other Kubernetes applications can connect to that and use them. Here's a super quick example of just how this, the logic within Kube would work. So if you look on the right-hand side, you can see we've got 3 different workers. So those are our compute pools, as I said. And then on the left-hand side, I've specified this is my desired state, a very simplified one. It says, okay, I want one pod containing image A and B, and I want 3 versions of that, right? So you can see Kubernetes has automatically put AB on each of the 3 worker nodes on the right-hand side. And then pod 2 is container image C, and I want replicas 2, right? So it's also put one pod with C in it, and it's put it on those top 2 worker nodes on the right-hand side. If this middle worker were to die, right, Kube knows, well, I still need 3 versions or 3 instances of pod 1, which contains AB, running. And I no longer have that. So it's automatically scaled it and put 2 of them onto the worker node at the bottom. And it's also moved C down there as well, so that we're always maintaining that desired state. The same thing could happen with scaling. So in this example, this is back where we were, where we've got A, B on each of them and C on the top two. Well, what if I want a third version of C? Well, again, it knows like, okay, this worker is underutilized compared to the others. It also doesn't contain the same pod already. So it makes sense for us to deploy a new container C onto the third worker in the bottom right. There's also the kubectl, right? Kubectl is the command you type on the command line. It's a very powerful and easy to use CLI. It's the general, like, as you'd expect, right? Way it works is, kubectl and then action and then noun and then any other flags you've got afterwards. So kubectl create and then configuration file, or kubectl get pods, describe pod, which gives you more details. I'm not going to spend time on this because I'm going to show you this live now. So if I jump in and do a demo, right? So in fact, before I do, just to explain this, right, I'll show you the Kubernetes cluster I'm running. I've deployed this on IBM Cloud. The great thing about running on IBM Cloud is that they manage and take care of all the master nodes for you. So the bit that actually runs the clever Kubernetes logic and so on, and that you communicate with through the API and the CLI, that bit you don't have to run at all yourself. And all that you're in charge of are like those worker nodes that you provision, and the worker nodes are just your compute pools. So it's it's not really any different to like provisioning your own virtual machines, except that now you get all the power of Kubernetes on top of it, and all the headache of upgrading when Kubernetes come out with new versions or new features, checking whether it's supported with your underlying operating system, and then upgrading it and doing it all, like all of that's taken care of by IBM. So like for me, this is super easy. So I've created this cluster here. It's called my cluster, and just to connect to that, right? I need to tell my kubectl CLI like how it can communicate with that. So I'm just gonna do IBM Cloud Kubernetes service clusters, right? And so that will show me the clusters I have. And you can see that my cluster one I just showed is running there. So the thing I need to do now is IBM Cloud KS cluster config my cluster. And this will give me the configuration that Kubernetes needs in order to connect to that cluster. Right, so this is going to export a kubeconfig variable, right? And now if I do kubectl get nodes, that will now connect to that cluster, and it will say, okay, return all the worker nodes on there. So you can see this cluster only has one worker node down here. You'd have expected that anyway, because look, if you look at the cluster, it's being created with only one worker node. So this is a very simple, small cluster, but it'll do for what we're demonstrating here today. What I'm going to do now is I'm just going to show you like the quickest way to deploy a container straight away to Kubernetes. So if I do kubectl run, and then this is the name of my deployment, guestbook, and image equals IBM guestbook v1, right? So what I've done there is I've said when you run something, call it guestbook, and here's the image, right? And if I give it an image, this is actually a Docker Hub image. So if you're not familiar with Docker Hub, it's kind of like GitHub, but for container images. And it's going to go and get the IBM com guestbook image with the tag version 1, right? Because there may be multiple versions of it. And you can see it's created a deployment for me, right? So now if I go kubectl get pods, right? And remember, pods are like the smallest deployment unit we could create. You can see in here, there is one pod in there called guestbook. There's one of them, and it's already running. Okay, that's great. That was pretty quick. To access that pod and check that my application's running, I need to expose that as a service. So the way I can do that is I can go kubectl, let's type that, expose deployment. guestbook. And then there are different ways you can expose your deployments in Kubernetes. The simplest of these, right, is just to use a node port, which is essentially saying, like, I just want you to map one port on that host machine to the container inside so that I can access it, right? So in this case, I'm saying 3000. So what that command's doing is saying to Kubernetes, my container that runs in there wants to listen on port 3000. Can you please expose that somewhere on the host? Right, so if I do that, and then it creates a service, and I can go and let's look at that service quickly. So we go get service guestbook. Right, you can see that what it's done here is it's mapped port 3000 inside the container to 30,208 on the actual host machine. Right, so let's remember that because let's go and access this from a web browser in a second. But the most important thing is I need the public IP of the actual worker, right, or of my cluster that I created on IBM Cloud. So I can get that from the IBM Cloud CLI. I can go KS workers, my cluster. Right, and this will just list the worker nodes that are available in that cluster. And you can see this public IP here. So I'm going to take that public IP, and then just remember it's 30,208. So let's go. Okay, so hopefully this will show my guestbook deployed. Yeah, there we go. So we can see that this application is very simple. It's like kind of like a to-do list. It's a guestbook. You can just leave your notes. You can say, "Hi, Ed is here on a webcast." Right. So simple CRUD type application. Let's jump back here again. So now let's say, I don't know, my guestbook's up and running. People are loving it. It needs to scale. Well, I can do that super easily with one command. So I can go scale replicas equals 10 deployment guestbook, right? And I'm basically saying take that deployment, but this time run 10 replicas of it. And if I'm fast with this one, right, I can view the rollout status of that deployment. So you can see it's saying waiting for rollout to finish. 1 of 10 updated replicas are available. Now 2 of 10 updated replicas, 3 of 10. So what it's doing behind the scenes is it's starting new containers on my machine just through that scale command. And you'll see we now have, we have 5 of 10, and it says minimum required is 9. So it's going to get most of the way there before it'll let you successfully complete the deployment. The rollout. Nearly there. Cool. So it now says we've successfully rolled that out. Now, if I do kubectl get pods, which are my deployment units, remember, I can now see that I've got 10 of these in here. And if you look at the top here, that was the first one I deployed, which was 4 minutes ago. But the other 9 of them have all happened just now in the last minute. So I've now got 10 containers all serving that same application. But because I've exposed that as a service, if I go back to my web page and refresh it, right, I could be in any one of those instances each time. Right, so now let's say I want to deploy a different version of my application. How would I do that? So I can do kubectl set image deployment guestbook. So essentially what I'm doing here is changing that container image I've given it and said I want to just deploy IBM com/guestbook v2 this time, right? And you'll see my deployment guestbook image updated. So Kube has understood that. And now if I go back to the browser and I force refresh this, I may have to go incognito because it caches stuff sometimes. Is that updated? Did I type that all correct? So you get pods. Oh, okay. It was still updating. So I was too fast there. Kube's pretty quick, but because I've got a really small cluster with a tiny machine on it, and I'm trying to run I'm trying to create 10 new replicas. It wasn't quite as quick as I was in this case. So maybe if I force refresh it in a second, we'll get there. There we go. So now we've moved to guestbook version 2. You can see the color changed and now says version 2 up here. And I can type some new stuff in. You'll notice that the state was lost. Right, we'll come back to that in a minute. And you can see from these pods here that some of them were terminating and creating new containers. What actually happens when you roll out to a new version is that Kubernetes, by default, will do a blue-green deployment. So it creates, in this case, it will create 10 new containers with version 2 running. Then when they're healthy, it will start to terminate the version 1 ones so that we always have the application accessible and ready. But let me, I don't know, type some more stuff. Oh, no, what's happened here, right? I've got an error. I'm not really sure what this is, but I guess I should probably roll back my deployment here. Well, the good thing is I can do that super easy with Kubernetes as well. So if I do rollout, undo, deployment, guestbook, that will literally take the last rollout I did or the last change and just roll it back, right? And if I'm quick here, and I look at the rollout status, you can see essentially by turning it to roll back or like an undo a rollout, it's now going, oh, okay, I better deploy 10 versions of 10 containers of version 1 again. And then when they're all healthy, start to terminate the others from that are version 2. And actually, what I'll try and do is I'll show you while this is running. Here's a good example of kubectl get replica sets. So the way Kube manages these is it actually calls each of these things a replica set. And I can also use a label here so you can see what's going on. By using the -l flag and then key value pair, essentially I'm using those labels and it's searching to match those. And you can see there are 2 replica sets in there. One of which will be my version 1 of the app and one of which is version 2. And if I rerun that command, I should have fewer of each now. So now, yeah, you can see that version 1's back up and running, and version 2 is nearly finished killing all of those. Okay, what I'm going to do now is I'm just going to quickly delete this and then show you another way of deploying applications. If I could type delete, that would be helpful. Cool. So we're going to delete the deployment. And then delete service guestbook as well. So we deleted the service. And now if I do kubectl get pods, just check there's nothing running. Okay, there are 3 left that are still terminating. They've probably gone by the next time I run it, which they have. Okay, cool. So let's clear this. What you'll find from that, right? That's a really simple way of doing it. But I've deployed those with a pre-built image, and I haven't given it much information. I basically just said, like, here's an image, run it. Ultimately, what happens is when you run Kubernetes deployments, you end up writing a lot of these manifests in YAML, right? So here we go. Let's get this one open. So if you have a look here, this is a simple deployment, for example, and I'm saying within each of these manifest files that Kubernetes will accept, there's you always have to specify the API version that you're communicating with and the kind of object you're creating. And then you can put in as much metadata as you like, right? These can be all these labels and so on to be able to filter on them later. But the bit that Kubernetes needs in order to actually deploy stuff is your spec in here. So in the spec, you can see I'm defining replicas 10. Let's change that, actually. Let's say like 7 so that we can tell it's not deploying the same thing as last time. we've got a thing here where it's saying match labels where the app equals guestbook. The template here, we've now got, again, some more metadata around the container or the pod, and then the containers itself. So here I'm specifying the name is guestbook, but I want that IBM com guestbook v1, right? And then also I need to expose that port on 3000. And you can start to store all sorts of information in here. And the way I deploy that, right, is I just do kubectl create guestbook deployment YAML, right? So the kubectl create -f is basically like, here's a file, deploy it, right? And it knows that this is the deployment because I specified that in the spec here. I said kind deployment. It's created the deployment. It's named it guestbook v1 because I gave it the name here, guestbook v1. It will have used the containers, image I've specified, etc. And this becomes a much easier way of being able to deploy things and also store the configuration and not have. You can also use it to automate things, which is much easier. But also you avoid human error. You could do all of that from the command line, but it's a lot of commands or a lot of flags, and you could easily type some wrong. Whereas when you're storing it in a manifest, it's much easier to handle. The other thing I then need to do is I need to go and create a service. In fact, no, let's check this is deployed first. So get pods. Okay, cool. Yeah, so my 7 pods are up and running. I could equally have done thing to filter. Right, in this case, I should get import because all of them I have running are from that guestbook app. Seems to be a little bit slow responding, but there we go. Yeah, we get the same result. And then let me just show you how I can actually, that deployment I showed you, I can edit that deployment straight from Kubernetes, right? So what this does is it downloads a version of the deployment. And you'll notice as I scroll through this, that there's way more information in here than was in the deployment manifest I gave to Kubernetes, right? And that's because this is a copy of what's being stored in the database. And this contains all sorts of information about you can see the status here for available replicas, the conditions, so the last time it was updated, the minimum availability message on there and so on. But essentially this is all the stuff that Kubernetes has added to it before it stored it. So let's just quit that. Then what I won't do is I could have taken that guestbook deployment and then applied a change, but let's just deploy a service now instead. So let's have a look at that first. So service, and you'll see this service. Oh, let's go back again. Looks much like the deployment does. It's a bit simpler, this one. It's basically saying, deploy a service, match the selector here is looking for app equals guestbook. So all of the pods where the label app equals guestbook. And then I want you to load balance over that, and I want you to expose port 3000. Right, so there's my simple service. Let's do kubectl create guestbook service. Cool. And that should now be deployed. So it says service guestbook created. And then if I do once more, I go to my, let me get service. They're called hopefully guestbook. Yeah, so I just need to check that port again, right? So that because this time I've created a new node port on there, and I need to update that on my browser so we can go and check that that's still running. Oh, in fact, it is the same port still, so we're good. And you can see my application is now up and running. This time, I've deployed the same thing, but I used manifests rather than specifying the image myself and then writing commands in to do it. And then I can do the usual, it will take state. The only thing is, right, all of these haven't had a way to actually store the information I put into my guestbook. So very quickly, what I'm going to do is I'm going to deploy a Redis cache so that this application, when it takes information in here, it still stores it. Because if I refresh this, and I force refresh, because I have 7 instances, right? You'll see sometimes I get the response I typed in, but a lot of the time I'm getting blank, right? Because it depends which one I'm connecting to. That's not particularly good behavior for my application. So let's deploy a backing service to this. So kubectl create -f Redis master. And you can see this is much easier when I have these deployment manifests written up already. So now I'm creating a new deployment called Redis master. And you can see if I do, let's do the, this time my selectors actually do something because I have multiple deployments. So I'm saying match the labels where app equals Redis, role equals master, and still return the pods. And you can see I only have one of those running, this Redis master. I'm just going to copy that quickly because another cool thing you can do in Kube is you can do kubectl exec, right? And this will exec into the container is like SSH is in and runs a command for you. So in this case, I'm going to give it, so that's the name of the pod I want to connect to. And the command I want to run is Redis CLI. So if we jump in there, we can just check that Redis CLI is running, and we can go like ping and it responds. Okay, great. So that's fine. Let's just jump out of there. And then we also need to create a service for that one. Redis master service. So that service now will match that deployment we created so that it's exposed. And just in order to, so the thing I need to do now is the application has the code that's written for it is automatically going to try and connect to Redis if it's available. But because it's already up and running, it's now using in-memory database instead. We need to restart it. So there's no real concept of like a restart in Kubernetes because all your containers are supposed to be stateless and ephemeral. So the way we do that is we do a kubectl delete deploy guestbook v1. So I'm basically deleting my deployment I created. And then I'm just going to create it again. And I could have scaled the replicas to 0 and scaled them back up again. That would also have achieved the same same goal. And now if I jump over to my application, just refresh it quickly. I don't know if it's finished. See if those pods are finished creating. So they're still saying container creating. 2 of them are finished, so we might get a response now. There we go. Right, and now if I type something in and I say, hello world, if I force refresh this, regardless of which of the instances I connect to, I can see that state because it's being stored in my Redis service. And we can also, let's confirm that for sure by going into the, let's exec, hang on, what did I call that pod again? Oh, it's fine, it's there. Exec into the Redis pod again. All right, so we're now using the Redis CLI again inside that container that was storing the cache. And let's do, just see what this one's called. Okay, it's called guestbook in here. Let's just get the return the first, essentially I'm saying to it, return the first 10 rows of whatever's stored in this cache on the guestbook key. And you can see it's stored inside there is hello world. So my cache is working and it's replicating across all the containers. Fantastic. So I've now deployed a very simple but pretty powerful scalable deployment. The final thing that I was going to show but I won't do and I'll talk about instead is if I jump back to my slides. What I was hoping to have time to do was to say, now I've deployed a Redis master, how do we keep that scalable? Well, one of the ways we could have done that would be to deploy slave nodes to that Redis master. And what those slaves do is they replicate the data that gets stored in the Redis master across them, so we can have multiple instances of the database as well. And then the way the application behaves is it takes reads from those slaves, and any writes go to the master, and then they get synced across. And at that point, right, very quickly, within under an hour, whilst explaining it, we have like a 3-tier application that's fully scalable, highly available, on cloud, deployed with Kubernetes. And Kubernetes is now constantly monitoring that to make sure it's always up and running, which is a pretty cool and powerful way to have your application running. Again, like thanks to Kubernetes. So I'm going to open up very quickly to questions. Anisha, I don't know if you mentioned you were going to monitor if there were any. I don't know if do you want to let me know if we have any at this stage?
Yeah, people asked about advantages of using Kubernetes on IBM Cloud specifically, if you have anything to share about that. Or
Yeah, sure. Yeah, there's essentially, right, there's like 2 ways of running Kubernetes. You can either like run it and host it all yourself, either on your own infrastructure or in cloud infrastructure. Like a lot of cloud providers will spin up Kubernetes for you in a load of virtual machines and go like, here it is, like now it's your problem. And the problem with that is you have to manage and maintain all of the master nodes. You have to handle a lot of the networking that goes on underneath. You then have to stay up to date with Kubernetes upgrades, or you have to delete your entire later if you want to get benefits from the provider. The other way of doing it is like a managed Kubernetes environment, which is what IBM provide. It's what you get if you go to Google Cloud as well. I think there are some others who do it now too. Essentially, the benefit with that, right, is in this case, IBM manage those master nodes. They look after all of the Kubernetes type upgrades for you. There is still like an option you have as to when you want to upgrade. But the other thing they'll be doing is they'll be providing things like when your worker nodes like fall out of date or there's a security vulnerability within them, IBM will notify you and tell you like, here, all you have to do is run this command and we can upgrade them for you. But you've just got to be aware that you're working like, what your stuff is you've deployed on there and whether it might be affected. So it takes a lot of the headache of running Kubernetes away from you and lets you focus more on just deploying your applications and being an end user rather than an operations manager of a kube cluster.
Great answer. Someone else asked, where are the logs to the commands and service stored?
So where are the logs to the commands and service stored?
Perhaps they're meaning.
Was that the question? I think I know what they mean by that. I'm going to assume they mean like if I run, so when I'm running kubectl, like create service, etc., or something like that, right? I'm telling Kubernetes to do a bunch of things. Is there like an audit trail about that? Because one of my other developers might tell Kube to do all sorts of stuff. Yes, that's it's all stored in the so the API server that I mentioned earlier, like keeps an audit trail of that. I don't know how accessible that is. Like, so you can see it. I know when you run Kube yourself, right, you can see that. Whether through IBM Cloud, because it's like a managed service, you may have to, if you had that request, you may have to open a support ticket and just request, could we see all the audit trail for our commands in there? But ultimately, like you want to get away from in a multi person environment, you want to get away from running as many commands as possible, and you want all of this to be handled by automated tooling that in reality you write your code, you check it into your Git repository, and that triggers some sort of delivery pipeline that builds your code into a container. It deploys it off to Kubernetes. It asks for a certain number of replicas, etc. And the only thing that the developers kind of in charge of is maybe like changing a few bits in the configuration that they then have to check in with their code anyway. So you then have a full audit trail from that side. And that's probably a better way to handle it in a multi-user scenario. Any other questions? Anisha, do we have any more questions, or is that all? Shall I wrap up there?
Yeah, I think that's all for questions. So anyway, thank you to Ed. And as I said before, for more information, in the description box of the video, there's an event page, and there you'll have links to more resources on how to get started, along with a link to how to sign up for IBM Cloud. So thank you, everyone. And that's our Tech Talk.